Although oil palm occupies only 6% of the world's land used for oil crops, it supplies nearly 40% of the global vegetable oil market. This astonishing level of efficiency has transformed Malaysia's endless rows of oil palm plantations into a massive industrial machine. Yet beneath this impressive system lies one of the most intense controversies in modern agriculture. One half of the world bitterly calls palm oil public enemy number one, an industry accused of destroying vast areas of ancient rainforest to make way for industrial plantations. The other half, including millions of farmers across Southeast Asia, sees it as a savior, an economic engine that helped lift their countries forward after independence. So what really happened behind the extraordinary expansion of this so-called green gold? Join Mandarin Tech as we uncover the full story in today's video. In the mid-1950s, many rural areas of Malaysia were still trapped in poverty. In response, the government created FELDA with an ambitious plan: open new settlements, provide farmland to poor families, and build an entire economic system around them. The journey of the oil palm begins in carefully controlled nurseries. Seeds are selected from high-yielding varieties, germinated, and planted in small nursery bags under sprinkler systems. Each seedling is monitored for leaf color, growth rate, and overall health. Weak or abnormal plants are removed early because problems at this stage can affect the plantation for years. After several months, the seedlings are moved into larger bags, allowing their roots to spread and their stems and fronds to develop. For nearly a year, they are watered, fertilized, and regularly adjusted so they grow evenly. Meanwhile, the plantation is prepared in advance. The land is divided into blocks, drainage channels are dug, and transport roads and fruit collection points are planned. Planting holes are usually arranged in a triangular pattern about 9 meters apart, giving each mature palm enough sunlight. From above, the young palms look like tiny green dots across a vast landscape. But every row has already been planned to connect with future harvesting routes, transport vehicles, and nearby processing mills. This quiet order is how an oil palm plantation begins to take shape. In Malaysia, oil palms can be harvested all year round, although yields vary with the season, rainfall, and local growing conditions. To maintain high productivity, harvesters return to the same areas frequently, looking for fruit bunches that have reached the right level of ripeness. For shorter palms, workers use a steel chisel attached to a short handle to cut the bunch from the stalk. Young bunches may weigh around 10 kilograms, but mature ones are often much heavier. As the palms grow taller, the job becomes harder. Workers switch to a curved sickle attached to a long, lightweight pole. Standing beneath the thick canopy, they must find the correct stalk, guide the blade through narrow gaps, and pull sharply. A mature fruit bunch can weigh more than 20 kilograms. Once cut, it falls from several meters above, sometimes together with large fronds. Workers must keep the area clear, stand at about a 45-degree angle from the trunk, and constantly watch the canopy. According to statistics, nearly 30% of plantation accidents are caused by falling fruit bunches and palm fronds. The danger increases with palms over 20 years old, which can grow beyond the reach of aluminum poles. Workers may have to climb as high as 15 meters using safety belts, cutting heavy bunches among sharp, thorny fronds. Yet many are paid by output, earning only a few dozen cents per bunch. Even after working from morning until late evening, they may earn only around $15 to $20 a day. And the work does not end when the bunch hits the ground. Loose fruits scattered among grass, dry leaves, and soil must also be collected because they still contain valuable oil, making this another time-consuming part of the harvest. After leaving the tree, the oil palm fruit bunches begin the next stage of their journey. At first, these heavy loads are carried by workers onto wheelbarrows and small carts, which are then pushed out through the narrow rows of palm trees. However, in some plantations with swampy and waterlogged terrain, workers still rely on a very traditional form of biological power: water buffaloes. With their massive strength and remarkable endurance, the animals slowly make their way through deep mud, pulling carts loaded with heavy fruit bunches out of the plantation in an efficient and steady manner. At collection points, all the fruit is transferred onto larger trucks for the journey to the processing mill. On flat land, this process is relatively simple and fast. But on steep hillsides or more difficult terrain, Malaysia has also used an impressive industrial transport system: aerial cableways. Steel containers are suspended from cables and move between metal towers scattered across the plantation, carrying up to 500 kilograms of oil palm fruit on each trip. At the mill entrance, each truck is driven onto a weighbridge. The quality of the fruit is carefully inspected, and the entire load of dark red fruit bunches is then tipped into the receiving area. From this moment, the difficult journey through the plantation officially comes to an end, giving way to the heat of steam, the friction of steel, and the roar of massive oil pressing machines. There is one surprising detail. When oil palm fruit bunches arrive at the mill still covered with soil and leaf debris, they are not sent through a separate washing line. Instead, the entire load goes directly into large, pressurized steel chambers. In major Malaysian mills, production lines can process around 30-90 tons of fresh fruit bunches per hour, with some facilities reaching 100 tons. The doors are sealed, and hot steam penetrates deep into the tightly packed fruit. Pressure can reach around 300 kilopascals, while one sterilization cycle may last about 90 minutes. This process helps control microorganisms, deactivate enzymes that could quickly damage the oil, soften the fruit flesh, and loosen the fruits from their stalks. Once the pressure drops, the steaming fruit cages are pulled out and emptied into rotating steel drums. As the drums turn, the bunches are repeatedly lifted and dropped until the small fruits separate from the hard stalks. They then fall through openings into vertical digesters, where steel blades crush and stir the orange-red flesh, breaking open oil-bearing cells before the material reaches the most important stage, the screw press. Inside the press, rotating screws push the fruit pulp forward through a narrowing chamber. The pressure forces a reddish-brown liquid through small openings. But this crude mixture still contains water, fine fibers, and solid particles, so it cannot yet be used. The liquid first passes through filters and settling tanks, where lighter oil rises while water and heavier solids sink. Centrifuges then remove remaining water droplets and suspended particles. Finally, the oil is dried to reduce its moisture content. Only after these steps does the mill obtain orange-red crude palm oil. On average, 1 ton of fresh fruit bunches produces around 200 kilograms of crude palm oil, while the rest becomes kernels, fibers, shells, and empty fruit bunches. Yet the material left after pressing still contains another valuable product. Hidden among the fibers are hard palm nuts. These are separated, cleaned, and cracked open to release the white kernels inside. The kernels are then crushed and pressed to produce palm kernel oil, which has different properties from the oil extracted from the fruit flesh and is widely used in cosmetics, soap, detergents, and industrial products. Meanwhile, crude palm oil is sent to a refinery, where unwanted compounds, natural color, and odors are removed through several stages involving heat and vacuum. The dark red oil gradually becomes the familiar light golden color. The refined oil is then carefully cooled and separated into 2 fractions. The liquid portion is commonly used for cooking and frying, while the more solid fraction becomes an ingredient in margarine, shortening, confectionery, and processed foods. In this way, one simple palm fruit can produce 2 different oils and several valuable byproducts. This ability to generate high value from a relatively small area of land helps explain why Malaysia placed such high expectations on oil palm. But when millions of tons of fruit pass through these mills each year, another problem immediately appears. After the valuable oil is removed, what happens to the mountains of fiber, shells, empty fruit bunches, and wastewater left behind? After the valuable oil has been extracted, the mill is still left with a huge amount of material, including empty fruit bunches, pressed fibers, palm shells, kernel cake, and wastewater rich in organic matter. Instead of sending everything to waste disposal sites, many facilities reuse these byproducts to reduce costs and recover additional value. Pressed fibers and palm shells have a relatively high heating value, so they are often fed into boilers to produce steam and generate electricity for the mill. Empty fruit bunches can be chopped, turned into compost, or spread back across the plantation as mulch to retain moisture and add organic matter to the soil. Some can also be processed into fuel pellets or used as raw material for fiber products, boards, and biochar. The residue left after palm kernels are pressed can be used in animal feed. Meanwhile, organic-rich wastewater is sent into anaerobic treatment systems, where microorganisms break down the material and release methane. If this gas is captured, it can be used to run generators or help meet the facility's heating needs. The treated water is then further controlled before being reused or discharged into the environment. In this way, material that was once considered waste gradually becomes a second stream of resources. But this cycle only truly works when each waste stream is properly managed. Without effective control, the very same byproducts can quickly become one of the mill's biggest environmental burdens. From the outside, Malaysia's choice may seem difficult to understand. The country already had coconuts, while sunflower was also a familiar source of edible oil on the international market. So why was oil palm given such an important role? The answer begins with land. 1 hectare of mature oil palm can produce around 4 to 5 tons of oil each year, far more than most other oil crops. According to comparisons made by Malaysia's palm oil industry, oil yield per hectare can be about 4 times higher than sunflower. This means that to produce the same amount of oil, sunflower would require a much larger area of farmland. The production cycle is also completely different. Sunflower must be replanted after every harvest and depends on a concentrated harvesting season. Oil palm can remain productive for decades and continuously produce new fruit bunches. As a result, fresh fruit can keep flowing to processing mills for many months of the year, allowing equipment to operate more consistently, workers to have steadier employment, and growers to receive income in multiple cycles instead of depending entirely on a single harvest season. Coconut is also a perennial crop, but the amount of oil produced per hectare is lower, while collection systems in many areas are often scattered among small farms and require the coconut flesh to be dried before pressing. For this reason, Malaysia did not choose oil palm simply because it could produce oil. It chose a biological machine capable of turning limited land into high output, keeping processing mills running and creating a more regular flow of income for rural communities. Seen from above, Malaysia's oil palm plantations look like a vast green carpet stretching toward the horizon. But this uniform landscape also reveals the cost of decades of expansion. In some areas, natural forests have been reduced or fragmented, disrupting wildlife routes and pushing forest-dependent species, especially orangutans on Borneo, into smaller habitats. Yet the problem cannot be solved by simply boycotting palm oil. The industry supports hundreds of thousands of households, while oil palm produces far more oil per hectare than most other oil crops. The real challenge is therefore no longer how to expand plantations, but how to maintain production without pushing further into untouched land. This question is becoming more urgent as many plantations reach the end of their productive cycle. After more than 20 years, palms grow taller, harvesting becomes slower and harder, and yields begin to decline. Farmers must eventually cut down old trees and replace them with new seedlings. But replanting creates a difficult gap. Young palms need several years before they can produce stable harvests, leaving smallholders with sharply reduced income during the transition. Malaysia's future palm oil industry will therefore depend on shorter, higher-yielding varieties, plantations better designed for mechanization, and more efficient use of existing land. The era of expanding production simply by clearing more land is gradually coming to an end. The new challenge is to rebuild the industry without repeating the environmental costs of the past. Oil palm once helped Malaysia expand its production areas, build new communities, and move deeper into the global supply chain. But that success also left behind an important warning. Any development model that depends too heavily on land and natural resources will eventually reach its limits. Now, Malaysia must enter a new phase of transformation. Increasing productivity on existing land, supporting growers through replanting, and protecting the forests that remain. The lesson of oil palm is therefore clear. The strength of an industry is not measured by how much it can extract, but by whether it can preserve that value without destroying the very foundation that made it possible.